name is A. Nikhil Sai. I am from CSC D section. In this presentation, I am going to explain the conductometric titration of HCl versus NaOH. What is conductometric? Conductometric is a technique in which we measure the electrical conductance of a solution. The conductance depends on how many ions are present. If there are more ions, the conductance will be higher. In titrations, as ions decrease or increase, the conductance also changes. Principle of conductometric titration. The principle of conductometric titration is that conductance changes when ions in the solution are neutralized or replaced during titration. As the concentration of ions keeps changing, the conductance also changes. The endpoint is found by plotting conductance versus volume and identifying the sharp change or minimum point. Reaction involved. The reaction involved in this titration is HCl reacting with NaOH to form NaCl and water. HCl gives H plus ions and NaOH gives OH minus ions. During titration, H plus and OH minus combine to form water. After that, the solution mainly contains Na plus and Cl minus ions. The conductance changes because H plus ions have very high mobility compared to other ions. Before titration. Before starting the titration, the conductance of HCl solution is very high because H plus ions have the highest mobility. The initial conductivity mainly depends on the presence of H plus ions. During titration, NaOH is added slowly to the HCl solution. The H plus ions combine with OH minus ions to form water. So the number of H plus ions decreases. As a result, the conductance keeps decreasing. At the end point, all H plus ions are neutralized and the conductance is minimum. After the end point, the conductance increases again because Na plus and OH minus ions start increasing. Conductance versus volume graph. This is the conductance versus volume graph. On the x-axis, we take the volume of NaOH added, and the y-axis, we take the conductance. At the first, the conductance decreases because H plus ions are getting neutralized. The minimum point of the graph represents the end point. After that, the conductance increases again due to addition of Na plus and OH minus ions. So the graph looks like a V-shaped curve. Apparatus required. These are the apparatus required for the experiment. We need a conductivity cell and a conductometer to measure conductance. A burette of adding NaOH beakers, a pipette or measuring cylinder, HCl solution, NaOH solution, and optionally a magnetic stirrer. Procedure. The procedure is as follows. First, take a measured volume of HCl in a beaker and place the conductivity cell in it. Note the initial conductance. Fill the burette with NaOH and add it slowly in small increments. After every addition, stir the solution and record the conductance. Continue this process until the conductance decreases and then starts increasing again. Finally, plot a graph of conductance versus volume of NaOH added. Result. The result of the titration is obtained from the graph. The minimum conductance point represents the end point, where all the H plus ions are completely neutralized by NaOH. The volume of NaOH at this minimum gives the equivalence point Conductometric titration provides a very sharp and accurate endpoint. Conclusion. Advantages of conductometric titration. These are the advantages of conductometric titration. It does not require any indicator, so it can be used even when the solution is colored or turbid. The endpoint is very accurate because it is based on conductivity changes. It is also suitable for weak acids, weak bases, and weak dilute solutions, since conductance can be continuously monitored. Conclusion. In conclusion, conductometric titration is a simple, accurate, and sensitive technique. It is especially useful when the solution is colored or turbid because no indicator is required. For HCl versus NaOH, the endpoint occurs at the minimum conductance point. This method is ideal. For strong acid, strong base titrations and gives a clear graphical representation of the endpoint. Thank you.